welcome to our talk about Quarkus and Azure Container Apps. So it's going to be a talk with a few slides and a lot of demos with superheroes and supervillains, as you will see. So my name is Antonio Goncalves. I'm a software developer. I've been doing Java for many years, let's say 20 plus. I was involved in Java EE at a very early stage, so early that it used to be called J2EE. And now I'm still a little bit involved in Jakarta EE, but mostly with new things such as Quarkus and Micronote and Spring Boot. I've been speaking at several conferences throughout the decades. I've also published a few books, and today I'm a principal software engineer at Microsoft. So I work with Java on Azure. So that's also the topic of this talk, is how we deploy Quarkus application onto Azure. Eric, that's for you.
Yeah, my name's Eric Deandreas, and I'm a developer advocate here at Red Hat. And Tony and I have had a lot of fun over the last, I'd say, what, year or so ago, doing talks, but also helping to build the content and try and hype up Quarkus between both Red Hat and Microsoft. So very happy to be here, talk to you about this. I've been a contributor to open source projects for a really long time. Unlike Antonio, I skipped the whole Java EE thing completely. I went right from Swing to Spring, and never really dealt with Java EE. So you're moving on from Spring, where I've done some contribution in the past, to now Quarkus, where I contribute part-time to Quarkus. I'm certainly not on the core development team or anything, but I do some contributions, and I do talks at various events, and kind of like we're here today. So that's me. Okay,
so what will we be talking about? As I said, we will be talking about Quarkus, deploying Quarkus microservices to Azure. And for that, we will use a demo, so it's a bit more visual and a bit more fun. So the demo is actually about superheroes and supervillains. So what I'm going to do? I'm going to do the demo while Eric explains how it works. So hopefully you can see my screen now, and I'm, here I am in front of the demo. Hopefully you can see it. So yep. I'm going to play while Eric is.
Yeah. So we tried to think of something, and this comes from the official, or official, unofficial, whatever you want to call it here, the sample application for Quarkus. And we'll talk a little bit more later on what Quarkus is and why it's so cool. But we wanted to get something more real world. So even though you kind of see, we can click around, we can pit heroes and villains against one another, and we can, pit them against one another. And if you click the little icons under their pictures there, each villain and hero, it's got a bunch of superpowers. And there's a really super duper complicated algorithm that decides who the winner is. And it's really not that difficult to figure out. It's pretty much based on this level that each superhero and villain has, but it also keeps track of all your previous fights and who the winners and who the losers were, and the date and time that the battle happened. So that's pretty cool. The next screen that's there, do you have the statistics screen up?
Oh, no, I forgot to copy the URL. Sorry about that. Yeah, there's some statistics, but maybe we can have a quick look at the statistics if even statistics.
Yeah, it should be right up there at the top there. There you go, boom. So there's a bunch of statistics that it gathers, and it keeps track of as if you make your screen a little bit bigger.
Yeah.
So as the battles happen, there's that little slider. It keeps track of the different teams, like who's winning, who's losing, and it also keeps track of the last the top 10 winners and how many fights that they've won. And this all kind of, as you can see, it happens in real time as you're playing with it. So it's kind of cool. And there's a bunch of other ancillary UIs that really aren't that important for the purposes of this demo, like the heroes and villains. If you want to look at who all the heroes are, who all the villains are, and look at the data and whatnot, there's a few other screens, but like I said, not as important for this demo. So that's basically it. The demo itself,
Yes.
the application itself. So pretty simple. Looks pretty simple, but
it is complex. So we try to really make the entire application as complex as we could. I'm sure that if you are front-end developer and you just saw the application, you went, oh, with a bit of JavaScript, I can do it on my own. We didn't do that. We are back-end developers, so anything we create has to be complicated. So really, the superhero sample application, if you go to the repo, it's made of several microservices. It's uses fault tolerance and metrics and health checks and several databases, Postgre, Mongo, Kafka in the middle. So it is quite complex. We also have CI/CDs pipeline and so on and so forth, and documentation. So really, if you want to learn Quarkus as well as go deep dive into some more advanced technology, this demo is perfect. So let me just explain you the architecture. So as you can see, there are a few microservices involved, and so if you look at the UI, so the UI is an Angular application, and we did package it into a Docker container. So it is a container totally isolated from the others. So when I click on any button, so new fighters or fight, the Angular application talks to one microservice, the fight microservice. It doesn't talk to other endpoints, so just the fight microservice. So when we click on new fighters, the Angular app invokes the fight microservice. And what the fight microservice does is it invokes both a superhero microservice and a supervillain microservice to get a random hero and a random villain, and gives back the results to the Angular app. That's why we can display those nice little icons, the level of power, and the description of the superhero or the supervillain. Then when we click on fight, as Eric said, the very complex algorithm to decide who is the winner or the loser is within the fight microservice. Once we have a winner, it is stored on a MongoDB database. The fight is stored there. It's the list that you can see at the bottom. But also the fight is sent to a Kafka channel. Why? Because as you saw, we have some statistics. So on the other side of this Kafka channel, we have another microservice listening to this Kafka channel, computing, doing some statistics, and with a WebSocket sends back the data to another UI written in jQuery using WebSockets and server-side events. So as you can see, there are a lot of the technologies involved, but we wanted to show that even if it's a complex architecture, we can still deploy it easily on the cloud, make it scale, and so on. Okay. So these microservices, as you can guess, are written in Quarkus. Eric, can you tell us a little bit more about that?
Yeah, absolutely. So as you can kind of see, we can give you the little elevator pitch here for Quarkus. And when we did this talk the last time, I think we only had like 20 minutes. So trying to shrink Quarkus, what is Quarkus, into 2 minutes wasn't was actually kind of challenging, but I think here we've got a few more minutes to talk about. So if you go on to the next slide, please. I bet Quarkus is a stack to build, and you probably would think I was going to say microservices here, but really what I'm going to say is a stack to build distributed systems, right? And a distributed system can be a bunch of different things that encompass a lot of different types of communication, whether it's HTTP or gRPC or GraphQL, whatever it is that you're talking about. Quarkus is a Java stack to help you build whatever type of distributed system that you want to build, providing a cohesive, fun, full stack framework, leveraging a lot of the things that you're probably already using today. And so if you go on to the next slide, if you think about what a typical Java framework does, you've got this separation, and I'm Italian, so I tend to talk with my hands. I don't know if you can see my hands. I'm probably wasting my effort here, but you've got this separation between build time, what happens at build time, and what happens at runtime. And traditionally, you're at build time is just, you're packaging, you're creating your artifacts. So Maven, Gradle, whatever build tool of choice, you're building your, in this case, an executable jar file, and then you're storing that in some artifact repository somewhere. And then at runtime, the JVM starts up your application. And there's a whole bunch of stuff, and I don't want to get into like the innards of the JVM, but there's a whole bunch of stuff that happens when the JVM first starts before your application is even like ready to be used by some users. So there's config file parsing, there's class path scanning for looking for annotations within your code to determine behavior and whatnot, where the JVM can finally build its model of kind of what the world looks like at that point in time, and then it can actually start executing things, building thread pools, building database connection pools, all that kind of stuff before your application is even ready to go. So if you go to the next slide, what Quarkus does is not a whole lot different. All that stuff is still kind of important, but it's when does Quarkus do that stuff? And so if you think about where we are today in today's industry, with containers and whatnot, if I have a container and I want to run multiple instances of my application, well, it's the same container, right? So a lot of the decisions that are made by the JVM and the annotation scanning and the config, reading the config files to configure your application, those are going to be the same choices each and every time that your application starts, right? So with Quarkus, it does a lot of that stuff. It moves it to the build time phase, where it can try to take a more closed world view of what your application looks like, but still allowing for some runtime flexibility. Things like, where's your database, or where, what's the URL to some endpoint you're going to talk to, or how many threads, in your thread pool or in your database connection pool, stuff like that. We can leave and configure at runtime, but are you really going to switch, like talking from Postgres to Oracle, like within the same app, and have both database drivers in the same? So that kind of stuff doesn't make a lot of sense to leave those decisions until runtime. And so the benefit you kind of get with this model, if you go to the next slide, is the ability to do native images. And so when we talk about native images, there's, we traditionally run Java applications on a JVM, but with, recent technologies that have come out, being able to take these Java applications and compile them back into native binaries. So in the case where I'm going to run on Linux, it would be, a native Linux executable. We've kind of come full circle in technology. I remember when I started back in, God, I'm going to date myself now, in the 90s, when I started with technology, you had to, even when I was in college, with languages like C, C++, or even assembly, you had to build separate artifacts for each target platform that you were going to run on. And then Java came in. It was like a breath of fresh air, because now I could just write my code once and I could run it wherever I want, as long as, the JVM does that interpretation for me. But we've kind of come back now, where now we're going to take that JVM and we're going to compile it back to a native image. And why? Because it's super small and it's super fast and allows us to scale our applications and use far less resources than a traditional JVM app uses. But and I don't mean to like make this sound like it's not a big thing, but the design choices that Quarkus made from the onset, the fact that I can compile to native image, and when this started like almost 3 years ago, was almost like a side effect of the design of the framework in the first place, right? Because Quarkus was born in this era, it didn't need to retrofit this capability onto something that already existed. It could keep that choice and that capability in mind when it was being built from scratch. And so if we go to the next slide, one of the big things that Quarkus does is, we hear these terms: imperative, blocking, reactive, non-blocking all the time. Quarkus tries to simplify that for developers so that it all gets unified into a single, whether you want to call it code base or whatnot. At its core, Quarkus is based on a completely non-blocking engine powered by Eclipse Vertex and Netty, which handles all the non-blocking operations. But I know, when I first started writing non-blocking code, and Antonio, feel free to add your testimony to this, it's hard, right? And it's really confusing, like if you don't understand and how it works. And so with Quarkus, you don't have to make that choice if you don't want to. Quarkus will figure out what it is you're trying to do. If you want to use non-blocking APIs and paradigms, go for it. If you want to be blocking and use imperative constructs, go for it. You can even mix and match in the same classes, and Quarkus doesn't really care. It is smart enough to understand when you are trying to do one or the other, and it will behave appropriately. So if I want to write imperative code, it will, under the covers, switch that to a blocking or a worker thread and block and wait for that work to complete, and then merge it back into the IO thread. But the power of this is this all happens at build time, not at runtime. So it's actually generating the appropriate bytecode for the JVM and the just-in-time compiler at build time, which is pretty cool. And you can force it one way or another. Like if I have an endpoint that I write imperative, but I know it's non-blocking, I can kind of give it some hints and tricks and tell it if it doesn't do the right thing. So if we go to the next slide. And one of the big pieces, the memory usage and startup time, regardless if we're talking native image or JVM, is pretty impressive. But the big thing that we hear from a lot of users and customers and whatnot is the speed and velocity at which the developers can increase their speed and velocity in their what we call our inner loop development cycle. So from I need to start working on something, prototype it, build it, test it, and then commit it to source control for my outer loop to start. So things like developer productivity, the live coding where I can write code and it recompiles and redeploys it and reruns it in the blink of an eye without me having to go back and do like Maven compile or Maven test. All these things that are just kind of built into the framework and don't require things like IDE plugins or whatnot. If I want to use VI to write my application, I can, and I still get all this benefit. And if you go one more slide here, at the end of the day, you don't really have to learn anything new. It's based on all these different technologies that you're probably already familiar with and already using, Kafka, Hibernate, JPA, JAX-RS, Camel, Flyway, Liquidbase, just to name a bunch of them. A lot of the MicroProfile, a lot of these technologies that you're probably already familiar with and you're probably already using are just there. It's not like oh God, I got to go learn a whole new framework now. So I think that was a little more than 2 minutes, maybe 5 minutes. So that's kind of the why Quarkus is so cool.
So actually, we will not be showing you any Quarkus code or developing those microservices. As we said, the architecture is quite complex, quite rich. So the idea is not to show you some code and compile it to native or things like that. What we've done is, if you go to the repo with all the code, you have all the scripts, you have everything. And what we've done is packaged all these microservices into containers, push them to a registry, and then we will be deploying those containers. So that's what we will be showing more than developing with Quarkus. It's more about deploying to the cloud. So we will be deploying them on Azure Container Apps. Azure Container Apps, it's quite new. It has been GA for a few months. And basically, it's a way to manage containers. In Azure, we have Azure Spring Apps, and it manages Spring application. And this is Azure Container Apps. So package anything into a container, and Azure Container Apps will take care, of it. The idea is really for you to focus on the application and not the infrastructure. As you might know, Azure also have Kubernetes implementation. It's called AKS. And in AKS, you have to write your Kubernetes files. Here, you don't have to. Well, actually, you can't. Even if underneath Azure Container Apps runs on Kubernetes, you cannot access it. So you focus on the apps, you deploy them within containers. It can be Node.js as our Angular application. It can be any sorts of Java. It could have been Spring Boot or Micronaut. Here it's Quarkus, Go, or whatever. And you deploy those containers into Azure Container Apps. And then the idea is it will scale dynamically your application based on events. So it's built on Kubernetes, but it also implements several open source projects like Kida, which is the scaling part that we will talk about later, Dapper, and Envoy. So if you know a little bit the Azure platform, you have several ways to deploy an application. The more control you want on the left could be VMs. In Azure, we have Azure virtual machines. You have a VM, you log into it, and you do whatever you want. You have full control of it, but you also have to, make sure it's up and running, patch it, and so on. Then you have all the orchestrator part with Azure AKS, Azure Kubernetes Service, and also Azure Red Hat OpenShift. So you can also do that, and you have to write some Kubernetes files and so on. Azure Container Apps sits more on the productivity side of it, with the Azure Functions. That's another example, or the Spring apps that I was talking to. So Azure Container Apps sits more on the productivity side of it and less on the control side of it, like AKS. And of course, at the very end, you have all the low code, no code frameworks in Azure. So Azure Container Apps sits more on the productivity side. You do not have to care much about your infrastructure. You don't have to do any magic to scale up and down. And what can you do with Azure Container Apps? It's a serverless platform, but a lot of people associated serverless with function. It's not the case. You can add functions, but in Azure Container Apps, you can deploy any kind of application. We will be doing microservices with REST endpoints, but we will also be doing a web app. We have an Angular application. But you can also have even processing, and that's the statistics microservice. Each time we fight, we send a message, and at the very end, you have Quarkus microservice listening to those channels. But you can also deploy background processing within Azure Container Apps, some kind of batch processing that is triggered every day at midnight or something like that. Okay, so Azure Container Apps is not only for functions, because we always think of serverless. It's, you can deploy anything as long as it's containerized. There are several ways to deploy something in Azure Container Apps. Bicep is one of them. Terraform is on the way, but something that we all love is CLIs. So with Azure, there's an Azure CLI that you might be aware of, and Container Apps, it's one extension. So I'm not going to show you all the scripts, but I'm going to show you a couple so you can get a feel of it. So to deploy a container to Azure Container Apps, you have a command line, AZ, and then a container app, and you create. So this will be creating an application on Azure. On Azure, everything is grouped in what we call a resource group. So everything, the Postgre databases, the Mongo databases, the Kafka, the logs, the metrics, the microservices, everything is grouped within a resource group. With Azure Container Apps, you give it an environment. So you have to first create an environment and then deploy everything inside this environment. And the good thing is this environment will take care of the network. So you don't even have to worry about the network and opening ports and linking resources to others. It's taken care of within this environment. You deploy your container. Everything has to be containerized. So of course you need to give it the full name of this image. Here it's in Quai.io. It could be on Docker Hub. It could be on Azure Registry. The idea is to give it the image of the container to deploy. You give it a name. Here I'm saying that I need an external access to the UI, because I can either have a microservice that it's totally private within this environment and not accessible from outside, which could be villain and hero. But here it's the UI. I want it to be accessible from outside. And because it's a container, you can pass environment variables, so the container is deployed with the right values. Typically, the UI needs to connect to the Fight microservice. The Fight microservice is deployed somewhere in Azure, so you need this URL. So that's one way of doing. If we look at this Fight microservice, it can be, it is more complex because it has several databases and so on, but the first lines are always the same. You create a new application within the same resource group, within the same environment. It's a different image. As you can see here, all our microservices have been compiled with Java 17 and on native binary. So that's why we have the tag at the end, native Java 17. And then we set a few different variables. As I said, the Fight microservice is the more complex one because it needs to send messages to a Kafka server. Here we give it the URL of this server, a security configuration to access Kafka. Also, it stores all the files into Mongo, so that's one way of doing. And it needs to talk to Superhero and Supervillain, which are two microservices that are also deployed. So I'm not going to show you all the scripts, but basically you have Azure CLI commands to create a Postgre database, to create a Mongo, to create a Kafka, deploy your containers, and so on.
Antonio, I think we're using all native Azure services for this too, like Event Hub and the managed Postgres and managed Mongo and all that stuff, right?
Yeah, that's true. Actually, I'm going to show you the Azure portal. I'm going to make it bigger. So here I'm in the resource group superhero, as you can see on the top left. And a resource group, think of it as a a bucket with a bunch of things inside. So as you can see, I have each time I have a type of container app. It's a microservice that it's an application that we have containerized and deployed. But here we are using the MongoDB, um, the MongoDB implementation of Azure, which is called Cosmos DB, because it does a bit more than just Mongo. Same for Kafka, everything is managed. We have here a Postgres database. We have all our microservices. We have this container app environment. So think of it as as a shell where everything in it is accessible throughout the network that you can also configure. We have some load testing, and I will show you how it's load tested, logs that we can scroll and so on. Let me show you something. REST villain, it's the microservice that gives you a random villain, and we have told Azure Container Apps that this microservice can scale down to 0 up to 25. That means that after a timeout, a few minutes, Azure Container Apps will go, well, you haven't been used for a long time, so I'm going to scale you down to 0. If we look at the metrics of this microservice, there's this metric called replica count. And if we go in the last 30 minutes, we can see that it was scaled to 1 because we were using it. Remember, we were playing with the app. But now it looks like it went back to 0 automatically without me doing nothing. So if I go back to supervillain, and if I click on new fighters, it falls back, okay? The fight microservice tries to invoke superhero and supervillain. They both went scaling down to 0, and we did implement a fallback mechanism. So that's why you see fallback. But because I've clicked, Azure Container Apps has intercepted this call. Of course, the microservice wasn't there, so we did fallback. But behind the scenes, it went back scaling up to 1. So now if I do new fights, both microservices are up and running. Okay.
I think too, we put in like a very small timeout just to kind of demonstrate the functionality. In reality, you probably wouldn't get this, but I think it's like, if it doesn't come back in a second, we kill it and return a fallback just to show the fault tolerance stuff.
Yeah. So I'm gonna do something more. I'm gonna scale that up. So as I said, the automatically scaling is made by Keda, a Kubernetes-based event-driven autoscaler. And that's quite interesting because when I told you that many different apps can be deployed in Azure Container Apps, microservices, and so on, they have a few different scaling mechanisms. First of all, each microservice can be scaled up or down depending on your needs. Typically, our microservice fight scales down to 1. Same for the UI. So the UI and the fight microservice scale from 1 to 30. And superhero and supervillain, to show you the fallback mechanism, can scale from 0 to 0 up to 30. So you can scale independently your microservices. Your REST endpoints and web application will scale up and down depending on the HTTP requests. So that's what's going to happen. And we also have automatically scaling based on the number of message in a Kafka channel in a JMS queue. So if we scale up, we create new fights that creates more messages into the Kafka channel. And at the very end, we have one replica of statistics, but Azure Container Apps can say there's too many messages in the Kafka channel. I'm going to scale up. And for the batch processing, it can be the same thing. It can scale up or down the level of memory and CPU. So this is done by Keda. So Keda is all the auto scaling. To load test, I'm going to use another Azure service that is still in preview. It's called Azure Load Testing. And what I like about that is Azure Load Testing. You can, there's a wizard and you can create your load testing campaign and so on, but you can use your good old JMeter script. And that's exactly what we've done. Again, if you go to our GitHub repository, you will see the JMS script that you can run either locally or on Azure. Okay, so I'm going to show you that. Yeah, and then I will show you some statistics. So if I go back to the Azure portal, I've told you that here there's load testing. So I can create as many test campaigns as I want. I only created one, make them fight. So as you can imagine, this load testing, this JMeter script only invokes the fight microservice. But we could have, create a new hero, delete a new villain, or whatever. So this campaign I've already started several times. It's just a matter of clicking on run, and what it does is it takes our JMeter script and execute it. So unfortunately, I should have done that a little bit earlier because it's going to take a couple of minutes. It's going to take a couple of minutes to run the JMeter script, which basically uses 2 threads and iterates 10 or 15 or 20 times, I can't remember the number of fights. So I will leave it here and we will come back to it in a few minutes. But just to show you the end result will actually be, this is the scaling up and down of the fights microservice. So as you can see, we set the minimum of replica to 1. So if you look at the bottom left, it's always 1 replica, whereas superhero and supervillain can scale down to 0. Then we've executed this load testing. So the number of replicas went up automatically because Keda noticed that it was receiving a lot of HTTP requests. So it just scaled up. The load testing campaign finishes, and after a few minutes, Keda goes, well, looks like this microservice is not used anymore. So let's scale down to 1. Okay. I can, yeah, it's not there yet. But if I go to REST fight and look at the metrics, and again, I take the number of replicas and it's going up. So it's in the process. If I refresh, maybe it will go up. Now it's still at 4 replicas, but it might, so it looks like the load campaign is going up. Anyway, I will come back to it at the very end. Eric, do you want to talk about more resources that we have on Quarkus and Azure Container Apps?
Yeah, I think we've got a few minutes left, and then we can see if there are any questions. But just to kind of start to wrap up some things, and I don't know if we did publish the slide deck, but we will publish this slide deck so people don't have to be like doing screen grabs trying to get URLs and stuff. So put your cameras away. but some resources for people to take away with. There's this book that you and I have both written. You've actually written more than I have, but got this book that I wrote towards the end of last year, early this year, looking at Quarkus through the lens of someone who's familiar with Spring. I know myself personally, I've got a lot of experience with Spring. So when I first started to pick up Quarkus, or in general, when I learn something new, it's always comparing and contrasting to things that you already know and are familiar with. So kind of taking that theme and looking at different types of applications, RESTful applications, persistence, event-driven, Kafka, the cloud, and looking at, hey, how would I do that in Spring? And then look at how would I do that in Quarkus, and not just how would I build it, but how would I test it? So those who don't know me, I tend to have a big focus on testing, because if you build something and you can't figure out how to test it, is it really that good? Right, is kind of my theory. So looking at different like for like examples and whatnot. And it's a free book. It's not, I don't make any money on it, but definitely hopefully it's helpful for folks. There's also a on InfoQ. InfoQ did this series earlier this year about just native Java in general, and how the landscape has changed for Java with this whole native capability. And there's a bunch of different articles. There's one that I helped write on Quarkus, but along with the Quarkus co-founder Jason Green and John Klingen, talking about Quarkus and native Java as it applies to Java and Kubernetes in the cloud world. There's other articles in the series as well that were authored, for Spring and Micronaut and whatnot. So that's definitely a good resource to check out. And next, please. I think this one is about you.
Yeah, and while Eric was writing one book, I was writing two books. So these two books are also freely available on the Red Hat portal. So one is Understanding Quarkus. So it's basically explain you what Quarkus is, focuses on the main APIs. And then you are Practicing Quarkus, which is really takes you by the hand, and you go step by step and end up creating a microservice architecture. Slightly easier than what we did with the superheroes, but same idea, and really takes you step by step. So we've shown you the superhero app. Here is the repo. Everything is there. The JMeter script, the Java code, the test, everything, the documentation and everything. So please have a look at it if you are interested. We also have documentation which explain you how to deploy the entire architecture into Azure Container Apps. So you did see it already deployed, scaling up and down. Here you have all the instructions how to do so. You can do it by hand. Eric created a shell script, so you just go shebang and it does everything for you. So that's quite nice. And this sample app comes from a workshop that was created 3 years ago, or even a bit more, at the very early stages of Quarkus. So again, make sure you go on quarkus.io, Quarkus Workshop Superhero, and you will, it's a workshop that takes you by the hand again, and you develop this entire application. And Eric created a few blogs to detail the architecture of superheroes, don't you?
I did. Yeah, like you said, with the magic script, I'm always about the easy button. I don't like to click. I just like to push a button and it's just done for me, right? That's how life should be. I want a sandwich, boom, easy button.
Talking about button, if I go back to yes, and you can see it's scaled up to 10, and in a few minutes it will scale down. So
yeah, then I guess the last piece is, if you're interested in learning more about Quarkus, and we do the Quarkus World Tour, which we visit globally, either some in person, some virtually, different jugs or Java users groups, or within your organization, if it's something that you're interested in, we could try to arrange what we call a private stop, where we come in and we jam with you guys for a little bit and teach you what you want to know and talk to you.
Well, that's it. Thanks for attending. We do have one question in the chat about the ID support. So I use IntelliJ ID, and the Quarkus support is great because I can start an app just by clicking. So I don't know, Eric, if you use another ID and you have more, information on the support.
Yes, I like you, I'm an IntelliJ person, and like IDEs to developers are like the holy grail. You're not going to get a developer to switch tools, right? So like I said, the Quarkus support in IntelliJ is excellent. I've used VS Code as well. I'm not a fan of VS Code, but to each their own. There is the support for Quarkus is really good. Like I can do all the same things. I'm not blocked from doing anything. I haven't played with Eclipse in a really long time, so I really can't speak to Eclipse. I haven't touched Eclipse in years. Hopefully that answers the question. And I don't think with IntelliJ, there is a plugin that you can get from Red Hat for it, but I think IntelliJ itself, at least I pay for the Ultimate Edition, and IntelliJ just has built in, but I don't know if that's specific to the Ultimate Edition or if the Community Edition has it too. But there's free plugin anyway if you don't. I don't see any other questions. I think we got 2 minutes. So thanks everybody for coming. Hope it was informative. Great working with you again, Antonio. It's always a pleasure.
And we will see you physically in a conference in a few weeks.
Yeah, we'll both be at DevOps Belgium in a couple of weeks doing different talks, not this talk.
Yeah, that's true. So, if you were at this talk and you are in DevOps Belgium in a couple of weeks, come and say hello.